So the first chapter that we had done was our prologue. And in the prologue, we talked about measuring things. And then we talked about finding volume, finding mass, and so on. So we're going to start from the beginning and remember how we do that. So we want to use the metric side of the ruler. And on this ruler, I've already taped over the other side, so we can only use the metric side. And we have our centimeters. 0 to 1 is a centimeter. Each of the small lines are our millimeters. You guys remember this? We have done it. Make sure that's all focused. Okay. So if we want to measure things, like our wooden tile, which you remember from the beginning of the year, we want to make sure that our 0 is at one end of it, and we can see the rest of it. See right here? Want to make sure that we're not measuring from the end of the ruler. You always want to check on that. So what does this read? And let's see. Can I zoom in? We can probably zoom in, right? Let's see. Yep. Okay. Very exciting. So we can see what this is reading. Our length on this is going to be 4.3 centimeters. So write that down. Wooden tile, length equals 4.3 centimeters. You always want to make sure you write down what you're doing so you don't forget. And then we can do our width. Put that where you can see it again. And you can read that, 2.1 centimeters. And then the height, going to be, do that carefully, 0.7 centimeters. Cool. Volume equals length times width times height. And yes, I am going to write everything out. 4.3 centimeters times 2.1 centimeters times 0.7 centimeters. And we put that into the calculator. You guys see the calculator? Oh, there we go. 4.3 times 2.1 times 0.7. So we end up with this nice long number, 6.321 centimeters cubed. Centimeters times centimeters times centimeters is centimeters cubed. What we can do in this case, since we only had our measurements out to the 10th place, we can just round this off to the 10th place. And since the number after our 10th place was less than 5, this is left alone. 6.3 centimeters cubed. Awesome. Now, the other thing that we've learned to do is we can also look at what's the mass of a thing. So here's our scale. Yes, I did bring a scale home from work. And it's zeroed out. I can take my tile, put it on there, and I have a mass of 3 grams. Can you guys see where it says 3? 3 grams. So we can write that down too. Mass equals 3 grams. And our density formula, density equals mass divided by volume. 3 grams divided by 6.3 centimeters cubed. Calculator again. Mass 3 divided by 6.3. Now, we have another big long number here. And again, we're going to round this one to the 10th place. 0.476 blah, blah, blah. 4 is our 10th place. 7 is greater than 5, so that rounds this up. So it is now 0.5 grams per centimeter cubed. There was one other thing we had learned when we talked about density. If the density is less than that of water, density of water is 1 gram per centimeter cubed, something can float. This is less, so it will float. Exciting, right? Okay, let's give you guys some practice. What I'm going to do now is show you a couple of our different things. Again, I did bring these home from work. because that's who I am. You guys know how extra I am, as you always say. And I'm going to show you what the measurements are. You're going to enter them and figure it out from there. All right, so you probably are going to want at least a piece of paper to be able to write these things down on as well. So here's our metal bar for the first one of our things. Metal bar. Now I'm going to show you the length, the width, and the height, and then we'll look at the mass, and then you'll figure out the density on your own. So let me zoom in a little bit here, because you want to make sure you are precise as you can be. So first, I want you guys to write down the length. Okay, so you should be able to, let me put it over here so you can see it really nicely. And then the width. Oops, make sure that's in the screen where you can see it. Width. And then the height of our bar. Sorry, I know I'm totally off center here. Height. And then we'll take a look at the scale. Oops. And now you have your mass. You should be able to see that. And that's your measurements for your metal bar. And then you can figure out what is the density of the metal bar. And will the metal bar float? So we did that one. Next that you're going to look at is our acrylic cube. If you heard that meow, that was Gracie. She's supervising again. So, length, width, height for our acrylic cube. Remember though, if it's a cube, you only need to measure one of these. A cube, by definition, all of the sides are the same. So, let's do that. There, right there. That's your cube. That's going to be the length and the width and the height, because again, cube, all the sides are the same. And then we need our mass. So I'll put this back down. Now you should be able to see the mass. Oh, and our masses are in grams, by the way, because we are doing this in metric. And now you can figure out the density of the acrylic cube. Density equals mass divided by volume. And you can figure out if it would float in water or not. Then the last one I'm going to have you look at is our metal cube. Length, width, height, and then the mass. And here's the thing again, with a cube, as we just said, you only need to measure one side of it. So, and these are actually pretty standard cubes that get used a lot in science for different things. So this cube actually has the same length and width and height and volume as the previous cube. There's that. And then we will find our mass. And again, that mass is in grams. There we go. Okay. And you can figure out the density and whether it will float in water or not. So, remember again, density equals mass over volume. And for what we are doing, our masses are in grams and our volumes are in centimeters cubed. And that's what we've got. All right, hopefully that's not too bad. You can do this, let's see, we'll do this Edpuzzle, and then I will probably put some practice work on Google Classroom for you. And now I get to figure out how to make this thing stop.